Okay, so we want to touch on plane angle. So the plane angle XOP, okay, is formed by two rays OX and OP. The point O is called a vertex, and half lines are called the size of the angle. So it means that this OX is the initial side, and OP is the terminal side. Then our O is the vertex. So an angle generated in this manner is called positive in the direction of rotation. Okay, it's counterclockwise, and negative in the direction of rotation is clockwise. So if you want to find a positive angle, so if it is counterclockwise, it means that, don't forget we said this is the terminal side. So if it is counterclockwise, which means anti-clockwise, then the angle generated by this manner is positive. So any angle which is positive, say 60 degrees, we measure it counterclockwise. Then the angle okay, which is clockwise, that gives you a negative angle. So this is a negative angle, and this is a positive angle. Okay, so take note of that. Okay. Okay, so let's come to radian measure. We'll throw more light on the angles again. So radian degrees are usually used as a unit of angles. Okay, so somebody can say unit of angle says 60 degrees, 75 degrees, Degrees are usually used as unit of angles. It's a way to know the angles. Okay. But radian is also used for circular measure instead of degrees. We use radian for circular measure. Note that proportionally, 180 degrees is equal to pi radian. 180 degrees is pi radian. So 1 radian equal to 180 over pi. Just write this by pi. Then 1 degree is also equal to pi 180 radian. Let's move on. Let's take some examples. So if I say convert, we want to convert from degrees to radian. So convert the following, sorry. Radian. So we want to convert the following. 1, 60 degrees. 2, 75 degrees. 3, 260 degrees. So what do? We said to convert from degree to radian. If you want to convert from degree to radian, we multiply by pi over 80. So the question given, we multiply by pi over 180. Okay. So this is the same as 60 over 180 pi radian. So this will cancel, and you'll be having pi on 3 radian, because 60 will go into 183 times. Okay. The second example, if you have 75 degrees, you multiply by pi on 180 radian. So you ask yourself, how many times will 5 go into 75? That'll be 15. Sorry. So 5 into 75 is 15. And 5 into 5 into 180 is 36. Although we can still, I think we can still do something about this. 5 goes into 15 itself, 5, and goes into 36, 12. So that's all. The third one, 160 degrees, you multiply by pi 180 radian. So the 0 will cancel 0. Then 2 into 26 is 13. And 2 into 18 is 9. And you need pi radian. So basically, that's how we solve questions like this. You can also convert the following. Radian to degrees. Let's get it. Let's use the same answers we got and see whether we get back to the question. Okay, so if you want to convert from radian to degree, what you do is you multiply it by 180 over pi. So this is radian. You can just omit it. So now we have pi will cancel pi, then 3 into 180. This pi will cancel this pi. 3 into 180 is 60 degrees. 15, 36 pi. You multiply by 180 over pi. This pi will cancel. Now, you realize that 36 will go into 36 here 1, 36 here 5. Then 5 times 15, this is 75 degrees. Last question, 13 over 9 pi radian to degree. So we multiply by 180 over pi. So pi, if it's pi radian, they will cancel. So this pi radian will cancel. Then 9 here 1, 9 here 20. Then 20 times 13 will give you 260 degrees. So if you look at it carefully, we started from 60, 75, 20, 260. We converted the answers that we got. We converted all those answers again from radian to degrees, and we are converting back to the 60, 75, 260 again. You see. So whichever way, you get the same answer. So we now come to reference angle. Reference angle R for an angle theta in standard position is the positive acute angle between x-axis and the terminal side of angle theta. So that's a reference angle. So you are interested in the angle it makes with the positive x-axis. So This is a table that can help us identify reference angle with ease. In quadrant 1, please, all students take coffee. This is quadrant 1. In quadrant 1, your reference angle, your reference is equal to the same angle. And right here, all the trig ratios like and its inverses, they are all positive over here. Okay, so over here, all are positive. In this quadrant, all are positive. In this quadrant, sine is positive. Its inverse also positive. Then the remaining are negative. Over here, tan is positive. Its inverse is positive. The remaining are what? Negative. Cos is positive. Its inverse is positive. The remaining are negative. We'll come to how you can identify. I'll be showing you how you can identify that these are the respective inverses. We'll come to that. Now, the reference angle in quadrant 2 will be 180 degrees minus your angle theta. In quadrant 3, it is your angle minus 180 degrees. In quadrant 4, it is 360 minus your angle. In quadrant 1, we say all is positive. In quadrant 2, sine and its inverse. Its inverse, the inverse of sine is cosec. They are all positive. The remaining are negative. Then in quadrant 3, tan and its inverse is cot. They are positive. The remaining are negative. When it comes to quadrant 4, cos and its inverse, the inverse of cos is sec. They are positive. The remaining are what? Negative. Okay. Now let's move on. Let's try and take some questions on it to understand it better. So find the reference angle theta for each angle. A. Theta is 94 degrees. So let's try them and see. So first of all, if you want to use the table that we used in the previous example, you will see for theta equal to 94. Let's go back and see. For theta being 94, you realize that 94 is in the second quadrant because this is 90, second 90, third 90. So 90, 180, 270, 360. And so 94, you realize that it will be in this quadrant. And don't forget, we said that if positive, if it is the angle is positive, we move in a counterclockwise or anti-clockwise. That's why we're moving like this. This becomes the terminal side. Terminal side means terminal means end. So wherever we reach, we end. So going back to it, 94, if you want to use the table, it means it falls here. And with that, we're going to use R equal to 180 degrees minus theta. R equal to 180 degrees minus 94 degrees. And with 94 degrees, you're going to get 86 degrees. Now, if you want to sketch this, 94 is over here. So from here to here is 94. So what's the angle it makes with the x-axis? Don't forget, we said the positive x-axis. Okay, so I'm not looking for the angle here. I'm looking for the angle it makes with the positive x-axis. This x-axis. So the angle it makes with the positive x-axis So from here to here is 94. So 94 plus what will give you 180. So from all here to here is 180. So if from here to here is 94, 94 plus what will give you 180. So that will give you 86. So here is 86. That's if you want to use the diagram. If you want to use the table, which we learned, this is what you use. Now, let's come to the second question. Theta is equal to 245. Who can tell me what quadrant is this? This should be in the third quadrant. And with the third quadrant, this is what we use. Theta minus 180. So you just write your R equal to theta minus 180. Your theta is going to be 245 minus 180. Then 245 minus 180 will give you what? Who can give it to me? That should be 65 degrees. If you want to sketch it, from here to here is 90, 180, 270. 270 will be reaching here. We are looking for 245. But from here to here is 180. So we are interested in the angle, it means the S axis. So it is from here to here is 180. 180 plus what will give you 245 is 65. So the angle here is 65. Don't forget, we are interested in the angle, it means the positive S axis, not here. Okay, if it is here, then we can say 270 minus 245. But because I'm interested in the angle, it means the S axis. From here to here is 180. 180 plus what will give you 65. 180 plus what will give you 245 is 65. So here is 65. Let's consider the last one. Okay, so when it comes to 290, 290 falls in the fourth quadrant, right? So in the fourth quadrant, with what we learned, the fourth quadrant, what's happening? Your reference angle is 360 minus theta. So 360 minus what's the theta? 290. So when you subtract, what are you going to get? 70 degrees. That's the answer. Now, if you want to maybe illustrate on the sketch, from here to here, 180, 270. Then 290 will be somewhere here. But don't forget, we're interested in the angle, it means the S axis. So if from here all the way here is 290, 290 plus what will give you 360 is 70. So the angle should be attached to the positive X axis. You see that? All right. So that's how we saw reference angle. But if, for example, the question were to be theta is equal to 60, and say find a reference angle. In the first quadrant, your reference angle is equal to your angle. So it means that the reference angle is still 60. We'll get it. All right. Let's move on.